created about 4.5 billion years ago. Various formative processes have been taking place in the Earth's core and its surroundings since the beginning till today. These have resulted in the formation of various ores. In today's topic, we'll learn about ores. How do they look? What are their colors? How do they react with other metals, etc. Today, Shubhajit and Hemlata will give you a brief idea about the properties and occurrence of metals from class 10 chemistry. In today's lesson, we shall learn about physical properties of metal, physical properties of non-metal, chemical properties of metal. Keywords are malleable, ductile, sonority, metalloid, aqua regia, ionic. Let's start the video. This is the concept map of today's lesson. Around us are in the form of some or the other elements or their compounds. In the beginning, elements were classified by their chemical and physical properties into the types of metals, non-metals and metalloids, and these are in use even today. We are going to get more information about them in this lesson. Metals exist mainly in solid state. The metals, namely mercury and gallium, exist in a liquid state at room temperature. Some non-metals are in a solid state while some are in a gaseous state. Bromine is the only non-metal which exists in a liquid state. Metals possess luster. The metallic luster goes on decreasing due to exposure to atmospheric oxygen and moisture, and also in the presence of some reactive gases. Non-metals do not possess luster, but iodine is the exception as its crystals are shiny. We know that metals have properties, namely ductility and malleability. Ductility is a property by which metal can be drawn into thin wire, and metal is called malleable when it is beaten into a thin sheet. Non-metal does not have the property of malleability and ductility. Similarly, all metals are good conductors of heat and electricity. Non-metals are bad conductors of electricity and heat. Graphite, an allotrope of carbon, is an exception as it is a good conductor of electricity. Diamond is a bad conductor of electricity, but a good conductor of heat. Generally, all metals are hard. However, the alkali metals from group 1, such as lithium, sodium, and potassium, are exceptions. These metals can be cut with a knife as they are very soft. Non-metals are not hard. Diamond which is an allotrope of carbon, is the exception. Diamond is the hardest natural substance. Metals have high melting and boiling points. For example, tungsten metal has the highest melting point, 3422 degrees Celsius. On the contrary, the melting and boiling points of the metals such as sodium, potassium, mercury and gallium are very low. Non-metals have low melting and boiling points. A sound is produced when certain metals are struck. This is called sonority. Metals are known as sonorous metals. Non-metals does not have the property of sonority. Metals are reactive. They lose electrons easily and become positively charged ions. That is why metals are called electropositive elements. Hold the sample of each of the above metals at the top of the flame of a burner with the help of a pair of tongs or a spatula. Metals combine with oxygen on heating in air and metal oxides are formed. Sodium and potassium are very reactive metals. Sodium metal combines with oxygen in the air even at room temperature and forms sodium oxide. On exposure to air, sodium readily catches fire. Therefore, to prevent accidents in the laboratory or elsewhere, it is kept in kerosene. Oxides of some metals are soluble in water. They react with water to form alkali. We know that magnesium oxide is formed on burning magnesium ribbon in the air. Magnesium oxide reacts with water to form an alkali called magnesium hydroxide. Drop a piece of each of the metal in separate beakers filled with cold water. Sodium and potassium metals react rapidly and vigorously with water and liberate hydrogen gas. On the other hand, calcium reacts with water slowly and less vigorously. The hydrogen gas released in this reaction collects on the surface of the metal in the form of bubbles and the metal floats on water. The metals, aluminium, iron and zinc do not react with cold or hot water, but they react with steam to form their oxides. Hydrogen gas is released in this reaction. When samples of aluminium, magnesium, iron or zinc are treated with dilute sulfuric or hydrochloric acid, sulfate or chloride salts of metals are formed. Hydrogen gas is liberated in this reaction. The reactivity of these metals can be indicated by the following sequence. Nitrate salts of metals are formed in the reaction of metals with nitric acid. Various oxides of nitrogen N2O, NO and NO2 are also formed by the concentration of nitric acid. Aqua regia is a highly corrosive and fuming liquid. It is one of the few reagents which can dissolve noble metals like gold and platinum. Aqua regia is freshly prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. Noble gases like helium, neon and argon do not take part in the chemical reaction. So far, we have seen from the reactions of metals that cations are formed by oxidation of metals. If we look into the electronic configuration of some metals and non-metals, it will be seen that driving force behind a reaction is to attain the electronic configuration of the nearest noble gas with a complete octet. Metals do this by losing electrons, while non-metals do this by gaining electrons. The outermost shell of the noble gases being complete, they are chemically inert. Sodium chloride is formed as sodium metal gives away 1 electron, while the non-metal chlorine takes up 1 electron. Magnesium and potassium from the ionic compounds MgCl2 and KCl respectively.